Hey, Stephen, can you hear me? Stephen, can you hear me?
Yeah.
Okay, cool. I tried to AirPlay into a speaker, but I guess that's not gonna, I'll play with that later. Okay, we can hear you. We have your screen share. People are starting to show up. The first person is. Hi, Andy. Nice to meet you. And yeah, I just basically have to admit people as they show up. And you will probably wait for about 5-10 minutes because oftentimes people don't have Zoom installed or that kind of thing. But why don't you put up your slide just so that people know, like when they get here, what's going on?
Yeah, I thought I did. Let me double check. I lost track of my screen somehow.
I just see it as black.
Yeah. Oh, let's see.
Oh, now we see it.
Okay. I don't know how that happened, but at least it's there now.
Cool. Oh yeah, I'm gonna have to manually click admit for everyone. But, yeah. How you been? How's Amazon?
It's doing all right. Doing all right. Some neat things happening in there. So yeah, so far so good.
We're treating TinkerPop right.
Yeah, I'd say so. Like I said, there's a fair bit of good energy so far. So we'll see how that keeps up.
Cool. Okay. Well, yeah. Looking forward to your talk. As part of keep interfering it, so may not interject with too many questions. But there's another one. Okay. Okay, I'm gonna go on mute, but then I'll unmute when the group is together. In the interim, if folks want to introduce themselves or say hi, now's the time.
I think you're on mute.
Let's try that.
That I can hear.
Okay. Hi. So I'm Andy Novik. I'm a SQL relational database guy, but
Okay.
I thought I'd learn a little bit more about other things. I thought this was category theory group.
I don't know how they let the graph guy in here. I don't know.
So
right? Yeah.
Not quite sure what to expect. Is this a category thing group? Category theory group?
Stephen's doing a guest lecture because, right, graphs are special cases of categories, right? So in particular, some of the work that we're doing, like at Connexus, for example, ties into Apache TinkerPop very directly, right? Categories are just graphs with extra structure. So that's how we see the connection. But yeah, I mean, it's a bit of it's a digression for the group, and we're all happy for Stephen giving this talk. I think it like Apache was supposed to host this talk, but then the pandemic happened, and or, something like that. Anyway, yeah, you can speak to that, Stefan, if you'd like.
Yeah, sure. This definitely was slated to happen in March at an Apache conference, and that kind of got canceled, and I don't know, when this opportunity kind of popped up in front of me, I thought this was a good kind of entry level, get to know Gremlin a little bit, get to know graphs a little bit, and so it seemed to kind of fit this space as a guest sort of talk. I had to extend it a little bit so that it fit this time format, but yeah, hopefully you find it interesting.
Is this going to be recorded and then available after too?
Correct. It's being recorded now. So actually everyone, yeah, be advised you're being recorded. It'll be made publicly available on the meetup website.
Oh, excellent. Thank you so much.
And for those who are just joining us, we're in the usual like 5 minute or so waiting for people to hop on and configure Zoom and all of that. So people who would like can introduce themselves to the group and chat. I'm going to go back on mute for a little while. Hi, everyone. Welcome once again. We're in the introductory period where we're just waiting for everyone to come on Zoom and that kind of thing. Our guest today is Stefan Mallette. He's talking about Gremlin language variants, which is related to categorical databases in that graphs are just special cases of categories. And yep, anyone who wants to introduce themselves to the group is free to do so now. We'll get started in a few more minutes. Participants in about 5 after, so I think we can go ahead and get started. No doubt some more people will trickle on in. Just got another person right now. Yeah, so once again, welcome to the Category Theory Meetup. We have a special guest lecture on graph processing, and as category theorists, we like graphs because, you know, graphs induce free categories and there's all that free math connection and all of that. So I think I'll go ahead and turn it over to Stefan. Please introduce yourself and yeah, take it away.
Okay, thank you for having me here. I think Ryan, it's maybe you forgot it's Stephen Mallette, but that's cool because people say that all the time. I'm happy to be here to speak with you all today. I hope you like different programming languages because I plan to touch on a lot of different ones today. We'll discuss graph queries and Gremlin language variants. There's a lot to unpack in that title if you're not familiar with the graph space. So to get started, I'll just kind of begin with some brief introductory explanations to just get everyone kind of on the same level. So let's start with the just the graph queries portion of that title and get through what is a graph. And it's for our purposes here, I think most people would know we're talking about graph data structure, specifically a property graph model where a graph is composed of vertices and edges, and your edge is this directional relationship between two vertices. And both vertices and edges have these labels and properties, which basically key value pairs associated with them. And the diagram at the bottom kind of shows it. If you can understand this diagram, you pretty much know what a graph is. You can see just how intuitive this data structure presents itself. In the center, there's a vertex called TinkerPop with the name TinkerPop. It has a group label associated with it. And once I have that vertex, if I want to learn something about what it's related to, I just simply follow the edges. I follow those arrows, those lines. And if I follow it to the left, I find that there's an includes edge, and it tells me that TinkerPop includes Stephen, who happens to be a person vertex in this graph. And once I'm at Stephen, I can find out things about Stephen by traversing further, and I can follow that nose edge across the bottom, and I can learn that Stephen knows someone named Divage. And then things get really interesting because I can then indirectly sort of find out that Stephen and Divage both are included in the TinkerPop group. So you can kind of see how that works. But again, if you understand that simple diagram, you kind of get the model that we're working with here. So to query this data structure, we're forming this notion of a traversal which implies navigating from vertex to edge to vertex and so on, collecting and manipulating, potentially manipulating data as you go. So you'll hear me use the word traversal and query interchangeably here. So when is a graph helpful? Typically, it's something where you have lots and lots of relationships. When you have lots of relationships in your data, you're going to have a very valuable graph that you're going to be able to query. And if you look at, and not every use case for data is a graph use case. So, you kind of have to, if you don't have any relationships in your data, the graph probably isn't the right thing for you. A quick search on graphs and their use cases will pull up these sorts of things, the fraud detection and recommendation systems and so on. So those are just kind of some top level things, but there's lots more you can do with them outside of that. So now that we kind of know what a graph basically is, the question is then what does Apache TinkerPop and Gremlin do to help support graph processing? So Apache TinkerPop is an open source graph computing framework. It provides a set of interfaces, protocols, serialization formats that graph databases and graph processor providers can implement to become TinkerPop enabled. And once they're enabled, they gain the functionality provided by the TinkerPop stack, which centers around the Gremlin graph traversal language. And that means you're able to query whatever graphs are support those, support the TinkerPop system. So you can think of this model quite similar to SQL and JDBC in the relational world, where the same SQL that you execute on Oracle is going to be the same generally. SQL you're going to execute on MySQL, okay, and it'll generally work on any JDBC capable database. So in that same idea, Gremlin will work on any TinkerPop compliant graph system. And there's a lot of TinkerPop enabled systems right now. I mean, pretty much most major graph databases do support Gremlin. So you have your, Janus Graph and DataStax Graph, Amazon Neptune, Cosmos DB, and so on, Neo4j. All of these support TinkerPop, and you can use Gremlin on them. So once you've kind of know what graph database you might use, and they all have their fine points that you need to consider in reference to your use case. But once you figure that out, then the question is, how do you go about building your application? How do you go about doing that part? And that's where Gremlin language variants come in. And I think this is where I tend to find Gremlin quite interesting and friendly to the developer because we essentially have implemented Gremlin in a lot of different programming languages. So Gremlin behaves as part of your programming language. So rather than embed SQL as some string in your application, you're really just working with Gremlin natively in your app. That brings the data and mixes it in kind of with your code. So it fits a little bit more seamlessly. So as you can see, many different languages are supported by Gremlin, and there are those that are supported and maintained by TinkerPop itself. So that's Java, Groovy, Python, C#, and JavaScript. And then there are those that are managed by the wider TinkerPop community. Those are like C++, Enclosure, and PHP, and so on. You basically need to, the benefit here, of course, is that, when you get to write Gremlin in the style appropriate to the programming language that you use, which should make the development process a little bit more comfortable for you. So you get your code autocomplete in your IDE. You're going to get some compile time checks for your Gremlin. You get those red squiggly lines when you upgrade and something's in the API has changed, for example. So you'll know when there's some issues, and ultimately that should lead to some better productivity.
Hey, Stephen, can we pause briefly for questions?
Sure.
Any questions from the audience? That was, quite an introduction, and this is ostensibly a category theory meetup. So I imagine there might be lots. So anyone? All right, well, take it away.
Fair enough. Let's see.
A question from the audience. Are there any books you can recommend in particular to learn about this?
Actually, yeah, there's a lot of them now. Well, a lot more than there ever have been. So there's certainly at the end of this, I have a slide that just has the resources that are out there. So when we get to the end of this, you'll see a list of books, but there's a couple that you can purchase. One that's free and online, and they're all really good. And yep, Dave just threw it up there for you.
It looks like there's the Amazon crew is rolling in tonight. Yeah, okay. Carry on.
All right, so how do you get started with Gremlin? That's kind of the question. You might know what programming language you like. You might see that it's supported. Really, how do you kind of get started? I tend to give the same advice with this over and over. You should start with what we refer to as the Gremlin Console. Okay, the Gremlin Console is this REPL environment. It doesn't necessarily have to be the Gremlin Console. It could very well be gremlify.com, which is this kind of a new web-based REPL. I'm not sure if I call it a REPL exactly, but it lets you visualize your graph and do some other things. I'll put it in the chat since we're just you can play around with Gremlin there, and some graph databases have their own notebook style environments. I know Neptune has their, Amazon Neptune has their workbook style environment. DataStax has DataStax Studio, but you just need something that's going to give you some kind of immediate feedback when you're working with Gremlin. You need something that allows you to type some Gremlin and then you get an error or you get your result, and you can iterate on that rather quickly rather than going through the standard compile, build, test kind of process. The next thing I think is important is to use, start with TinkerGraph, just because it's the easiest of graphs in the sense of it's like zero configuration to get it off the ground. It's in memory. You can make graphs, throw them away, and start from scratch. And you could load a pretty large graph into it if you really wanted to, and just generally easy to use. The last thing I think is really important is use a small data set when you get started. I know everyone's very eager to immediately start throwing petabytes of data that's been sitting around in some data lake somewhere into their graph to find out what neat things they're going to extract from it, but inevitably trying to push to figure out how to do that and do it well, and get your model right and all these kinds of things. If you don't have any experience with graphs and Gremlin, it's best to start with something really small. Maybe start with a toy data set like the one we're going to use today as I go through these the rest of these slides. There's the air routes data set that's in that book there that's referenced in the chat in Kelvin Lawrence's book. There's a bunch of different things that you could use, but you need something where you can easily predict the results, because if you can't predict the results, Gremlin can produce all kinds of interesting things. And if you're not sure what the result should be, it's going to be hard to tell if what you're doing is right. So you definitely want something where you can easily predict those results. So this is the Gremlin console and what it looks like. The Gremlin console is built on the Groovy shell, which means that you get the entire Groovy programming language at your disposal in this environment, which is sometimes really helpful. Given our heavy reliance on Groovy though in TinkerPop 2 and much of our documentation for TinkerPop 3 and which is our current version, and our mailing list, Stack Overflow answers, they all tend to use the Gremlin console out of convenience. And I think there's still some folks who think Gremlin is like this Groovy DSL of some sort. We still see questions about that, about how much they have to learn about Groovy in order to use Gremlin. That really doesn't exist anymore. Gremlin isn't a Groovy language by any means. And that's really not the case. So, the canonical representation for Gremlin is actually based in Java. And so, knowing Groovy is not really required. And I'll try and show that more today as we go through this. The Gremlin language kind of rises above the programming language it's implemented in. If you can visualize Gremlin in Python, you should be able to easily translate that over to Groovy, over to C# or whatever it is that you're working in. The key is to learn and think in Gremlin, and then you just need to come to terms with the intricacies of the implementation by the programming language itself. And so for our discussion, for our basic discussion points today, we'll be working with this modern toy graph. It just has it has like 6 edges, 6 vertices. We use it over and over again, pretty much for all examples. It's amazingly flexible in what kind of results it can actually show. I've reached a point with this thing now where you can show me just about any Gremlin and I could probably tell you what the answer is without even running it. If you want to experiment with any of the queries here in this, you can do that in this graph. The pattern for establishing a connection to a graph you want to work with is demonstrated here. The first thing is having a graph instance of some sort or some kind of reference to a remote one. Okay, in this case, we're using an embedded graph. In that first line there in our REPL, we have graph equals tinkerfactory.createModern, and that gives us a graph instance. Okay, it's embedded. It's embedded in this JVM. The next thing we need is G, or something we call G. It's really just a variable. It could be named anything. It could be X or Y or whatever you'd like, but typically by convention, we refer to it as G. And there, to get that, that's basically our graph traversal source, okay? And that holds configurations related to the graph connection, and it's responsible for spawning new traversals that you're going to execute over your graph. And to establish G, we call this traversal static builder method that creates this anonymous traversal source. It's anonymous because it's not really connected to anything until you say that it's with embedded, meaning you want to use it with an embedded graph, or it's with remote, meaning you're going to use it with a remote graph that's somewhere else. Okay, so those are basically your two sorts of options. Today we'll just be going with an embedded graph. So here are just some simple examples to get you a feel for what Gremlin looks like and how the language works. Gremlin queries are built by stringing together different sorts of steps that tell Gremlin what to do as he's traversing around the graph. So as you execute a traversal, you should think of it like a stream style of processing where data in the stream is kind of being pulled from one step to the next. So in this first one, this is like the G.V basically means Gremlin get me all of the vertices in the graph, and you can see it returns 6 vertices. Okay, pretty much all, for the most part, most traversals start with G.V, so you'll see G.V a lot. G.V has label person. It's just a filter. It's saying give me all the vertices that have the person label associated with it, and we get 6 of those, or sorry, 4 of those back. The next one's a little bit more specific. It's G.V has person named Marco, and that's going to give us good old V1. And it's just saying, find me the person vertex, or find me a person vertex with a name property key with a value of Marco. But once we have the Marco vertex, we might want to find out who the people are that he knows. And this comes into that kind of navigational aspect of Gremlin and moving about the graph, right? So G.V has person named Marco out, meaning go find the outgoing edges, or have Gremlin traverse the outgoing edges from that vertex, make sure they're nose edges, and then produce the adjacent vertex on the other side. Okay, so that's gonna, and then you're gonna do something called an element map, which is going to convert or transform that vertex into a map, into a dictionary or a map. And then lastly, we don't have to stop there, right? We can keep traversing. We can tell Gremlin to keep on going until there's just no edges left in the graph. And this one would say, find the people Marco knows, and then find the software that they've created, and then produce the values name, meaning find the values of the name property of those pieces of software. And for that, we get Ripple and Lob. So that's kind of a basic just introduction to just what Gremlin looks like in Groovy in this case, because again, we're in the Groovy shell in this case.
Stop here for questions?
Yeah, I was just about to.
Okay, so jump the gun then.
I shouldn't even have skipped off that
We
slide.
like Gremlins though, all the artwork. Anyway,
that's the fun part.
Okay, no more questions. So there's been some good discussion in the channel, but as usual, people should just feel free to speak up when they're up here. They just have want to dig in further. Anyway, back to you.
Okay. All right. So now that we've seen Gremlin in Groovy a little bit, that's the way we typically see it in examples in our documentation. You're going to see that in the books a lot of times. Let's start comparing it now to how Gremlin looks in other languages that you might end up using. So at the top here, we have Groovy, and below that, Java, okay? We can see the differences aren't really all that much, right? We still have to create G no matter what. They both have the same sort of way to do that. Use that traversal method or that traversal function, which would be followed by the with remote or with embedded, and that will give us our G. In the case of Java, we have to specify types for our variables, so we have to say that it's a graph traversal source. In Groovy, we just get to def it and call it a day. Same thing with our result. Okay, we have to have this list map object with all the nice generics and all that sort of thing in Java, and we just get to def our way through that in Groovy. Obviously, the single quotes versus the double quotes, that's just an element of the Groovy language or the Java language, depending on how you want to look at it. But for the most part, you know, the essence of Gremlin is pretty much the same. If you can read one, you can read the other. So if I were to give you the answer for a question about Gremlin in Groovy, the translation to Java really isn't all that hard. Since Java is kind of the canonical version of Gremlin, I'm going to kind of keep referring back to that instance as we go through the rest of these. When we compare it to Python, we again have that same pattern. We still need a G. You call this traversal method in order to get it. You're still going to have with embedded, with remote to be able to specify it. We'll talk a little bit more about that later for non-JVM languages. There are some caveats there with that, but again, not so different. One thing we have to introduce is this notion of since Python is a space-oriented language, we have to have those backslashes to indicate that this is the same statement that's being executed over multiple lines. So you have that backslash at the end of each line. Real Python masters here might notice that the naming isn't really terribly Pythonic. We should probably have element underscore map to underscore list with the lowercase letters. This was actually the first Gremlin language variant that we built. And I don't think we'd fully formed what the goal was for Gremlin language variants. So I imagine that at some point here, this will change and this will look more like idiomatic Python as it comes to naming and so forth. What's interesting is that when you compare that to Groovy, they're almost identical. They have the single quotes. Obviously, you still have to def things in Groovy. You might not even need to def things in Groovy if you're executing it in a shell. So this might even look even more like Python at the end of the day. So it's these two are actually really, really close. And I guess you could interchangeably use single quotes or double quotes in either of these cases. C# is an interesting case when we compare that to Java. Obviously, it uses like that Pascal case, so it has that capital H for has, the capital O for out, as compared to Java. We get our double quotes back, and those end up being the same. We do get a variable type in C#, so we can var and use vars instead of the actual classes for the types. The one bugger in C# is there's no type erasure. So with element map, you notice that we have to specify the generic. And I think that's the hardest of all. I think of all these you're going to see today, I tend to think C# is probably the hardest one to translate, only because if you weren't familiar with Gremlin, you might not be familiar with how each particular step, what each particular step's type requirements are, and you may not be familiar with what those generics need to be. So usually if I'm asked questions in like, how do I do this in C#, I have to like figure out what the generics are for folks. I usually don't just try and give them a Groovy answer, because the Groovy answer won't compile for them when they go to try and convert it over by just changing case. So C#'s one to kind of pay attention to. JavaScript, JavaScript looks almost exactly like Java in many ways, and except for the single quotes, so those could be double quotes as well. We again have variable types, so that ends up looking a lot like Java, but it also ends up looking a lot like Groovy to a certain degree, right? We have our defs instead of vars over in Groovy, but for the most part, these look really similar. And again, we just need. Oh no, that's still Groovy in JavaScript. My mistake. I was going to say something else. Let's see. So then we look at closure. I think closure is interesting, obviously, because it's a Lisp. So there's going to be a lot of parentheses in it. And this looks decisively different in a way, but in many ways still very much the same. We still have the same, you can still see the essence of Gremlin in this closure example. We still have to do G, we still have to have our list variable to store our results. We still need to do, have this terminator of a to list sort of thing. The steps are all the same, but the naming is a little different because we want it to look like closure, right? With closure, you have a hyphenated function names, all lowercase. So element map becomes element underscore map. Note how also that we get to use closure keywords for the syntax instead for property keys and for edge and vertex labels. And so that makes it a little bit more, a little bit, I kind of like it because it makes the language look, it kind of separates the data from the structure of the graph. So Marco being the data and the person and the name being part of the structure, for example. So I kind of like that syntax and the ability to have that in closure, and we'll see some more of that in some future examples. Another neat thing is note that it's into list rather than to list. In closure developers tend to see things more like, I think the APIs are more like, rather than to list, it's more like into sequence, into array. So for closure, we went with into list rather than to list because it would just make more sense to closure developers. Also notice the exclamation point on the end, the bang. A bang denotes in closure, it denotes, it's a convention that denotes the potential for a function to mutate state. So in this case, we're connecting to a data store. If you add some mutating steps in this traversal, it has the potential to execute some side effects, and the bang helps closure developers note that that's going to happen. So this kind of demonstrates Gremlin's commitment to adhering to the idioms of a particular language. Now we start getting into languages that I don't know terribly well, and I tried to get as educated as I could coming into this, but now we're looking at Rust. In Rust, I think this looks a lot like what Python might look like in some ways, right? We have those underscore, the underscore naming for our steps. I do see that there's this tendency to use, and I'm not sure, I don't know if there's any Rust folks around on this call today, but it'd be curious to know why the choice was made to pass arguments wrapped in a list into these steps. I'm not quite sure why that was. I tried to figure it out and I couldn't get it. But I thought that was kind of interesting. I don't know if that's a component of just something Rust developers are used to doing or not. I do notice there's a question mark at the end. It's kind of similar to the bang in closure, but for Rust, this is a shorthand for error handling. And again, we're seeing how Gremlin is kind of blending into the environment in which it's embedded. Here's Scala. Scala is kind of interesting, I think. I followed the pattern that I noticed in the Gremlin Scala example code, where keys and labels get defined as immutable variables. And so there's some form of type safety at play here with the name property key, which is kind of neat. It's a bit more verbose than what we see in Java, but I kind of wanted to adhere to what the Gremlin Scala developers are doing over there. So I kind of followed their form, but obviously you could probably write this in a slightly different way that looks more like the Java version, obviously. We have Elixir. That's kind of a exotic one. Elixir is a functional programming language that's built on Erlang. In this case, Gremlin steps are connected to one another by way of Elixir's pipe operator, where the result of one expression becomes the parameter in the next expression. So that fits the stream-like model of Gremlin's language really, really well. It uses this client query at the end as a terminator rather than the to list. So it's a slightly different way of doing it. But the essence, you can kind of still see the essence of Gremlin. We're still talking about a g.v has label person named Marco out knows element map. I mean, it's still the same thing. So I think if you were in Java and you need to convert that over to this, it probably, if you had a Java answer, you probably wouldn't have too much trouble getting over there. This is the Go in Gremlin. And again, it has a different type of iteration pattern where it uses this vertices by query. But again, if you look at the Gremlin itself that's being passed as an argument to that, that's very similar to what we would see probably, I guess the closest thing is maybe C#, although we dropped the generics there. And again, we can see where Gremlin is fitting into the language by returning this this pair from that, where we're getting vertices and then some kind of error object. So that is Go. I'll pause there for a second to just see if there's anyone has any questions on what we kind of saw that far, and then I'll move into some tips into some things that you might run into that might be problematic. But that's what's coming up next.
The audience wants to know how many of those languages there are, and if, yeah, you're going to keep going with another 50 of them, because that's a pretty exhaustive list.
I did forget. I'm going to stop there for sure. I know that was a lot, but I was hoping that, you know, we would somebody might see something that you know, a language that they tinkered with or enjoyed and would appreciate seeing the format in some way. I did leave off Haskell. I don't I'm on category theory beat up, and I just don't get it. So I tried to figure out how to rewrite these things, and I just couldn't get it right. So rather than make even a bigger fool of myself by putting that in a slide, I decided to leave that one out.
There's some good news for the group, right? Which is that in working with Marco on MMADT and Josh on APG and all that stuff, like the connection between this stuff and Haskell is becoming even more clear, right? So there is a Haskell there is a Gremlin for Haskell, but it's of the same form you saw here. But what we're doing now with our collaboration is actually like working out the category theory, for example, not just building an API. So yeah, we're all happy about that. I'll go back on mute.
All right, so just a few tips to kind of consider as you choose your programming language and start to work with Gremlin. You need to get familiar with the traversal iteration methods available in the programming language you're using. And we kind of talked about that a little bit. Here's that example with into sequence, which is something very specific to Clojure. We don't have such a thing. It doesn't exist in Java or JavaScript or anything else. Whereas JavaScript has its own kind of special thing with toStream, as stream is kind of a thing related to Java. So you just need to know how to iterate your traversal and what options are available to you and that are most fit your programming language the best. In JavaScript, it's the same kind of thing. You have you return a promise in their case that you might work with. So JavaScript developers are pretty familiar with working with promises. So that kind of fits into their flow of thinking. Some language variants have like syntactic sugar that you should kind of get to know. It helps you feel a little bit more makes the Gremlin feel a little more idiomatic inside that language. In the case of Clojure here, we have this, we talked about keywords already and how they can get used. They can also be used in other contexts, like with this step labeling with as. So step labels can use keywords, as can and then you can use them with select to select them out of the traversal and out of the path history. There's little things like that. that you should kind of consider. But get to know the sugar a little bit inside of these languages. Python has this range operator. Normally, if you want to split and splice up a list with Python, you can use this these square brackets, like 1,3. And you can apply those midway in the middle of a traversal. And that'll compile to the same traversal as what you see there above with range 1,3. There's something called Gremlin Translator implementation. These exist in a few of our languages, and they convert from one language to another. So there's times when that's really helpful. You might be working in JavaScript and you need to generate a groovy string of the Gremlin that you're writing so that you can submit it to submit it to a particular remote provider that only accepts strings, for example. Like there are some that only work that way. So these translators are kind of helpful in doing that. So get to know the translators a little bit. There really aren't enough of them. We need to build more, but at least there's a few that you can make use of right now. Let's run through some of the problems you might run into pretty immediately. First of all, each programming language has its own preferred way to construct anonymous traversals, and anonymous traversals are ones that aren't bound to anything. They're children, essentially, of another parent traversal, and until they're attached to that, they're kind of disconnected. So in Java, the anonymous traversal is this both e count. You can see that on that last line there, and that's generated by way of a static import in Java, but not all languages have static imports. Okay, so you can't just say we're just going to static import everywhere. In Python, the solution is probably best to assign that function to this, like a global operator, like both e, and then you can call it directly within your code. For Clojure, it's a little different. Clojure has this global namespace for the functions, so you kind of are stuck calling the double underscore. I don't know if there's any smart Clojurists on the call, but I'd love to hear if there's better ways to do that so that you don't have to have that double underscore in the way. But that's how we're doing it. That's how we do it these days. Another big problem is canonical Gremlin syntax can collide with reserved words of a particular language. So one of the things we run into a lot is something like the is step in Java. Obviously not a keyword in Java, but in Python, a reserved word. So what we typically do with reserved words is, at least in Python, is we suffix them with an underscore, and that gets rid of that conflict. For Clojure, it's a little different. You can just use an exclude operator and get rid of the core language conflicts. So in this case, count and filter. I can do that on that second line there for Clojure, and then we can just use then the Gremlin steps take precedence. It's typically not possible to bind anonymous traversal source instances to embedded instances in non-JVM GLVs, which usually confuses folks. So the point here being that, Java is both the Gremlin language and a Gremlin virtual machine. It has everything it needs in order to process Gremlin and to generate Gremlin and everything in between, whereas languages not on the JVM are meant to be more lightweight and tend not to have those kinds of all that functionality. So they can only connect to remote graphs that basically have that full Gremlin virtual machine out there. So in Java, you can have an embedded and remote. In JavaScript, which not running on the JVM, you're only going to be able to do a remote graph. Kind of piggybacking on that concept, there is no structure API in non-JVM GLVs. So something like a subgraph step, which extracts a portion of a graph out of a parent graph, right? That works really well for Java, where you have a graph to deserialize the result into. But for JavaScript, which doesn't have all that infrastructure, subgraph step has nowhere to go. It doesn't know what to do with the graph that comes out of it. That doesn't mean you can't subgraph, because that is a common use case, and I show how you can do that here. I won't go through it, but it's basically you can use other steps to extract the subgraph and then convert it into something you might use in JavaScript. You might be able to convert this into something that's fed into a visualization engine or some other format that you might use natively in JavaScript. That works pretty well. I don't know, that might change though. We'll see how things go with that kind of function. I know that that's a feature people really want to have. Subgraph is so commonly used, so we'll see what happens with that. GLVs don't have, again, don't have structure APIs, so all elements that we return from a graph, like vertices and edges, they're references only. So you only get the ID and the label, so all the properties are kind of left behind. That's why we use steps like element map to convert them into a map form that can be serialized and sent back over the wire. So again, that's just another thing to kind of look out for. This is a tricky one sometimes. Gremlin can return a lot of different data, a lot of different types of data. And you can conceivably generate a type of data that isn't valid in a particular language. The one we've run into consistently is with Python. For example, you might return a map where where the key is itself a map. And believe it or not, it's like a really common return type in Gremlin, because you do grouping on maps and it works great. And you return that, and then Python says, I can't do anything with that. And the reason Python can't do anything with it is because it's a dictionary type, and dictionary types aren't themselves hashable. And because they're not hashable, they can't be a key in a dictionary. So there are ways around that. We've actually solved that particular problem, but this one still exists that I show here in this example, where we're demonstrating that or returning that a map that has a list as a key, and again, not a hashable thing in Python. And so in this case, to get around that, I converted that map into a list of pairs, and then it's able to return in Python. So there are times when you have to convert your Gremlin and do a little extra transformation in order to get the data into a form that your programming language will accept. And last one here, I think last one for remote traversals. Traversal strategy implementations are applied on the server and not on the client. A lot of people don't kind of realize that one. Traversal strategies are essentially kind of the things that compile a traversal and do some rewrites on it to optimize it. And there's like tons of these things that execute every time you iterate your traversal out. And I think when they're used, they don't get executed locally. And so that means that if you have an architecture where you plan to build your own custom traversal strategies, you have to figure out how you're going to put them on the server. And that's not always something that's possible with all the managed graphs that are out there these days. So that's just something to keep in mind. So that kind of brings me to the end. Quickly, just kind of summarize and then look for additional questions. But Gremlin's a graph traversal language. It allows you to natively write queries in the programming language of your choice. Gremlin tries to obey the idioms and culture of each programming language. And if you saw something today where you're an expert in one of these particular languages and something didn't look like the way you would want to use it, I'd love to hear how something would work better. We're definitely striving to try and make these things look and feel as seamless as possible. So the key with Gremlin is really to just learn how to think in Gremlin, and then learn how Gremlin gets expressed in the programming language that you ultimately end up utilizing to build your application. And here are the resources that I promised earlier. Again, there's the free online book from Kelvin Lawrence, which is got to be like 600 pages of just like raw Gremlin. And then Dave's book, which is who's on the call here, which is coming out pretty soon, I think, and looking pretty good, is Graph Databases in Action. And then, of course, the Practitioner's Guide to Graph Data, which I think is a really neat book in the sense that it focuses a lot on use cases and graph schema and things that people always have questions about when they're trying to implement graph databases. That's a really nice resource. So I think that's it. Any other questions, comments, or thoughts?
There's one from the audience.
I see something in the yep, I got it. How many storage backends are there in Gremlin? Oh man, there's a lot. I think if you look on our website, tinkerpop.apache.org, and you scroll down, there's a graph systems section, and it lists all the ones that we are not necessarily aware of, but all the ones that meet our listing criteria. And then there's a few others that are working their way towards that. So there's got to be 24, I think, at this point listed there. Janus Graph kind of doesn't, I don't count all the Janus Graph backends, but if I did, it probably is a lot more than that even, because there's just always a new Janus Graph backend. I think Foundation DB was just, is being contributed back as we speak. So there's always like a new one of those.
Other questions? All right, well, if there are no more questions, then thank you once again. This was a great talk. Yeah, we just got someone to join now. That's kind of peculiar, but okay. Yeah, so so this at this meetup, we only had this one lecture planned. Sometimes we'll do two, but yeah, I think we can call it a day here, and then hopefully everyone will come back next month. The topic is still TBD, but we'll find one and send it out over the meetup. And yep, thanks again.
Okay, take care, everybody.
See ya.